Okay, after discussing the continuous facility location problems up to now, we will be discussing the discrete location problems. Actually, there are many different variations of this discrete location problems, and here we will be formulating some of these discrete location problems. So let's get started. The first model that we will deal actually is this simplest one for discrete location models. And in this one, we assume that there is a discrete set of potential locations for the new facilities. Okay, so it can be single facility location, it can be multi-facility location, okay? But what we assume is there are alternatives. So these are alternatives. I'm not saying that these are the locations of the existing facilities. The existing facilities, let me say, are represented by these red ones. These are existing. And these green ones are potential locations for the new facilities. And let's assume that we are going to locate two new facilities. Then what is let's say a solution to this problem? What can be a solution? Among these green ones, we are going to select two of them. Let's say this one and this one, and locate your new facilities to these 2 points. Okay, but then what is the relation, what is the interaction of these new facilities with the existing facilities? The thing is, these are assumed to be customers, the existing facilities, okay, customers, and these customers have a demand. Okay, so we assume that there are M customers, these red ones. There are N potential facilities, the green ones. And the customers have a demand that needs to be satisfied from the new facilities. Okay, and there is a cost of supplying the demand of a customer from a facility located at site J. Okay, what does it mean? Let me explain. So let's assume that this is customer 1. So if we satisfy the demand of customer 1 from this facility, there is a cost. Okay, we represent it with this C, Cij. Okay, it is C1. Let's say this is the first new facility, or this is not the first new facility, but the first potential location. Okay, then it will be C11, the cost. Okay, you can, initially we don't know, of course, which one of these green ones will be selected. Therefore, we have all these costs. Let's assume that this is the second potential location for your new facility. And if you satisfy this customer from this, then the cost will be C12. Okay, so for each customers and for each potential locations, there is a cost of satisfying the demand. And the thing is, this demand can be divided between multiple facilities. So what do I mean? Assume we want to satisfy the demand of this customer 1, and we are going to locate, let's say, 2 new facilities. What we can do is we can satisfy some proportion of this demand from this facility 1 and another proportion from this facility 2. It is possible. And if we say this customer has a demand of 100%, okay, this cost is the cost of supplying all 100% of that demand. Okay? But instead of satisfying 100%, let's say if we satisfy 30% from the first facility and 70% from the second facility, then the cost, okay, C11, we are going to multiply it by this percentage, because C11 is the cost of satisfying 100%. Now, if we decide to satisfy only 30% of it, it will be 0.3 times C11. And similarly, this one will be 70% multiplied by, let's say, C15, if this is the fifth candidate location. So this cost, again, given as the cost of satisfying all demand. And in this problem, there is another type of cost, which is this. For these candidate locations, the green ones, in order to establish a facility, there is a cost related to this one. And we call these type of costs as fixed cost or setup cost. Okay? This is the cost of locating a facility at site J. And what kind of a cost is it? If you establish a facility to here, then the cost is, for example, F2 or F1 for this first candidate location. But if you don't locate it, then it is 0. So that cost or fixed cost is only appears when you locate this facility to there. Now, what we are going to do is we will learn how to formulate this problem. And this problem is called incapacitated facility location problem. Why it is called incapacitated? Because then we are assuming that these new facilities do not have any capacity. So it is possible to satisfy all customer demand from a single facility. Therefore, it is called incapacitated facility location problem. Sometimes you will see these names also: simple plant location problem or warehouse location problem. They all refer to the same thing. Okay? So now let us think about how we can formulate this problem. First of all, in order to formulate such a problem, we need to consider the decision variables. Okay, what are my decisions? Okay, so we need, actually in this problem, we have two decisions. One decision is to identify to which potential locations I am going to locate these new facilities. So I will locate, there are n existing or potential facility locations. Okay, so what I'm going to do is, for this purpose, I'm going to define yj as a binary decision variable, and it will take the value of 1 if a facility is located on site J, and there are n such facilities, alternatives. Okay, so these are alternative locations. They are numbered. This is the first alternative, second, up to, let's say, n such facilities. And this yj takes the value of 0 or 1 with respect to where we locate these facilities. But of course, this is not the only decision. There is another decision which is related to the percentage of the demand of customer that we satisfy from the facilities. So it means that we have the customers located at different coordinates or different locations. And for example, if we establish a facility to the first candidate location and satisfy the demand of these customers, okay, and actually we want to understand what percentage of this demand will be satisfied. And it means that we can satisfy the demand of this customer, let's say this is customer 1, from this facility and this facility. And it can be some percentage coming from the first facility, another percentage coming from another facility. Therefore, our decision variable will be xij, which will be the proportion of the demand of, let's say, customer I satisfied from a facility located at J. So how many existing customers do we have? We have up to M. And how many potential locations we have? We have N. Okay, so now with these decision variable definitions, we need to write our objective function. In the next step, it will be the minimization of the total cost. And remember, for each potential location, we said that there is an associated fixed cost. If you establish a facility here, the cost will be F1. If you establish a facility here, its cost is F2. Okay, so we have these FJs, the fixed costs, or sometimes we refer to it as the setup costs. And there is the cost of satisfying a customer from a potential location, potential site. And it is given as Cij. For example, let's say that this is customer 2 and this C12 is to satisfy 100% of the demand of customer 2 from facility 1. Then using these, we can write our objective as, okay, it will be Fj, the fixed cost, multiplied by Yj. Remember, Yj is binary, 0 or 1. If it is 0, there is no fixed cost. If it is 1, then I'm adding up that fixed cost. And how many alternative facilities I have? J from 1 to n. This is the total fixed cost. Plus, we need to write the cost of satisfying the customers from different locations, and it will be simply Cij multiplied by Xij. So again, this J goes from 1 to n, which are alternative facilities, and I goes from 1 to m, which are for existing customers, which are the customers. Okay, so this is the cost that we want to minimize. And subject to, we need to write the constraints. What are the constraints? First of all, we need to satisfy 100% demand of all facilities, all customers, sorry. For each customer, their demand must be satisfied by 100%. So let's consider this customer over here, this one. We can locate a facility to here and satisfy some percentage or some proportion of its demand from there. We can locate another facility to here and satisfy some percentage from here. Another one may be here and satisfy the percentage. But in total, the total percentage that are coming from these facilities must be 100% or must be equal to 1. Okay? And in order to write this, actually, if let's say this is customer number 5, what I am doing, okay, X, remember, Xij is the proportion of demand of customer I. Okay, so this is customer 5, X5, 1. It is the demand coming from the first location to customer 1, plus 5.2, plus 5.3. Okay, all potential facilities, X5N, and this should add up to 1. Remember, these are proportions, and they will take values between 0 and 1, and their summation should be equal to 1. So in compact form, if I write it, it should be summation over all alternative facility locations. This Xij should be equal to 1. Okay, and this is for all I going 1 up to m. So for each facility, or the demand of each customer must be satisfied. Okay, this is the explanation of this constraint. There is one more constraint of this model. This is an easy model with only two sets of constraints. This is the first set of constraints that we already wrote here. And the second one is this. If you if you haven't established a facility to here, then can you satisfy the demand of these customers? Of course, if there is no facility, then there is no demand satisfaction. So remember, this is X53, satisfying customer 5 from existing location 3. And how do we know if there is a facility in this location or not? We know it by Y3. Okay, Y3 tells us that if there is a facility located in alternative site 3, and X53 is the amount or proportion of demand that is satisfied from 3. Simply, if Y3 is 0, then X53 must also be 0. So what do? We write Xij to be equal to or less than or equal to Yj. Simply, if this Yj is 0, you cannot satisfy any demand of the customers from this j. Okay? So I am going to write this for all I from 1 up to m, and for all j going from 1 up to n. Okay? And lastly, the sign restrictions. Xij are greater than or equal to 0. Actually, you can write it is less than or equal to 1. But because of this constraint, actually you don't need to write it, because here in this constraint we said that its summation will be equal to 1. If the summation is 1, then it cannot be greater than 1, simply. So writing only this one is satisfactory, and also Yj is a binary decision variable. It is 0 and 1 for all I and j. Okay? So this is your model formulation for the incapacitated facility location problem. So in this formulation, we have theseCijs, and we define it as the cost of satisfying 100% demand, all demand of customer I from a facility located in J. But how can we estimate this cost? What does this cost depend on? Actually, one way to find these cost values is it can be found by multiplying the demand of customer J in terms of the number of trips that we need to do to this customer, Ri, okay, multiplied by the distance between the customer and the potential location J, and which is multiplied by the unit cost of travel per distance. Okay, so then if we multiply these three, we can have the cost. Again, look, in our formulation up to now in continuous facility location problems, we tried to minimize the distance, the weighted distances and etc. But here we said that we are minimizing the cost. But still this cost depends on the distance. Okay, Dij actually is inside the distance. And another important property of these incapacitated facility location problems is this. We said that these Xijs are the proportion of the demand. Okay, it is between 0 and 1. And we are not expecting these Xij to be 0 or 1. It can take any value. It can take, for example, 0.5. What is 0.5 means? It is 50% of the demand is satisfied from that facility. But the thing is, when you solve this problem, at the end, you find that all decision variables, all xij's, either 0 or 1, you will never obtain a value of 0.5. This is a property of incapacitated facility location. Because there is no capacity constraints in this model, even though you don't restrict the decision variables to be zeros or ones, it will take the values of zeros or ones only. What does it mean? It means this. You have these customers and you establish, let's say, facilities, and these facilities or these customers, there will not be any situation that some percentage of this customer will be satisfied from this facility and some percentage from this one. This will never occur. It means that all customers will be assigned to a single facility. Okay? And it can be like this. These 3 are assigned to this facility and these 2 are assigned to this one. That's all. No customer will be assigned to 2 different facilities. And the most important reason of this is because in this problem there is no capacity constraints. We are assuming that these facilities can satisfy all demand of the customers. Okay? So this is the incapacitated facility location problem and how we formulate it. After this formulation, you can solve this with a solver like Cplex, or you can solve it using Excel solver or any commercial solver.